Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for May-June 2020, and the code is 9709/51. So please subscribe to the channel if you enjoy watching this video, and also share this channel with your friends. Thank you. Let's start. So now for question number 1, the score when two fair six-sided dice are thrown. The score is the sum of the two numbers on the upper faces. Now A, show that the probability of the score of 4 is 1/12. Right, so to get 4, we know that it must be 1 plus 3, 3 plus 1, or 2 plus 2. Okay, so the first number shows the number shown on the first dice, and the second number is the upper face number of the second dice. So now the probability. So since it's mentioned six-sided fair dice, that means the probability of getting 1 to 6, it will be equal, which is 1/6. So I will say 1 is 1/6. To get 3 is also 1/6. Right, basically all these probabilities with 1/6. Right, all this with same probabilities. Therefore, I will just times 3, because each one will be 1/6 times 1/6, and at last you will be getting 1/12. So that's the solution for 1A. Now the two dice are thrown repeatedly until a score of 4 is obtained. The number of throws taken is denoted by x. Find the mean of x. So now here, when you need to throw until you get a score of 4, that means this is geometric distributed. Alright, so now, and I know that to get the 4, the probability is 1/12. So that means basically x is geometric distributed with probability of 1/12. Right. So for your information, when x is geometric distributed with probability of p, the mean is 1/p. Okay, so from here I will say mean of x, ex, is 1/1/12. So in this case, that it will be 12. Okay, part C, find the probability that a score of 4 is first obtained on the 6th throw. Alright, so for this case, means that you have 1, 2, 3, 4, 5, then this is number 4. Right, and the rest of the 5 are non-4. Alright, so from here the probability remember, probability of getting 4 is 1/12. Right, so probability of not getting 4, bar means not getting 4, that will be 1 minus 1/12. I don't bother what is the sum, but as long as it is not 4, that is considered as failure. So this is going to be 11/12. So I will say that there will be 11/12 probability, but there will be 5 of them, because this is the 6th throw. The success, this is the 6th, right, number 6. Then the rest will be 5. So I will have 5 non-4 and 1 4. So then the probability of getting 4 is 1/12, and there is only 1. So this is the method of counting the probability. That will be 0.0539. Okay, now D, calculate px less than 8. So px less than 8, for your information, if x is geometric distributed with px less equals to small x, that is 1 minus q to the power of x. Alright, so that means now here I will just say this is less than 8 means is same as less and equals to 7 is up to 7. So now use this formula. Alright, so 1 minus the q just now we have counted, that is 11 over 12. So I will write here 11 over 12 to the power of 7. And at last, you will be getting 0.456. Okay, now for question number 2. A. Find the number of different arrangements that can be made with or from the 9 letters of the word, alright, jewelry, in which 3 E's are together and the 2 L's are together. So first of all, I need to write down the letters first. There are 9 letters here, but out of 9 letters, I have 1, 2, 3 E's. Okay, and then I have 2 L, and then I have 1 J, 1 W, 1 R, 1 Y. So I have another 4 others. Okay, now you need to arrange such that 3 E's are together and 2 L's are together. Means that now I will group 3 E's as 1, 2 L as 1, and then I have 4 others. Okay, but then the question does not mention must be starting with 3 E's and 2 L. That means I will have to arrange 1, 2, 3, 4, 5, 6. I have to arrange 6 of them. So the number of arrangements it will be 6 factorial. Alright, now 6 factorial. Then you look at here, 3 E's, these 3 are identical E's. And then these 2 L are identical L. That means now I do not have to arrange for the E's and L. Alright, because the 3 E's are identical and 2 L are identical. And some more, after you group the 3 E's as 1 and 2 L's as 1, then you still have 4 more others. Means that in general, out of these 6 letters, all of them are different letters. Therefore, the working is just 6 factorial. And at last, you will be getting 720. Okay? Now, part B, find the number of different arrangements that can be made with from the 9 letters of the word in which 2 L's are not next to each other. So now, I will exclude the 2 L, then I arrange the rest first. Okay, so when I arrange the rest, I will just write J-E-W-E, then skip the 2 L, another E-R-Y. So there are 7 letters here. So I arrange all these 7 letters first. Therefore, I get 7 factorial. Now, you should notice that out of these 7 letters, I have 3 E's. Okay, therefore, I must divide by 3 factorial. Otherwise, I will assume the 7 factorials means that you are arranging 7 different letters. But now, there are 3 E's. Okay, so it must divide by 3 factorials. Now, what happened to the 2 L's? The 2 L's are not next to each other means that it can be in any of the slots here. They will be in between. Alright? So when you calculate the arrows, the green arrows, it will be 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 slots for the 2L. So now out of 8, I need 2. So this is a second task, therefore it's times. Out of 8, I need 2. Right? So I will just write 8C2 because the 2 L's are identical. So after I've chosen 2 L's, 2 slots, that's it. So no need to arrange. If the 2 L's are not identical, instead of using 8C2, you have to use 8P2 because you need to arrange the 2L. But now 2 L's are identical. So we just use 8C2. So the green color is for the L, right? So then when you calculate this, it is same as 23520. So you have so many arrangements for this condition. Okay, so now let's move on to next part or next question. Alright, question 3. A company produces small boxes of sweets that contains 5 jellies and 3 chocolates. Gmail chooses 3 sweets at random from the box. Now, draw up a probability distribution table for the number of jellies that Gmail chooses. Right? So now we are interested to get the jellies. So and then you can choose maximum 3 jellies here. So now let's say X is the number of jellies. So when Px goes to 0 means no jelly, therefore means that it will be 3 chocolates. Alright, so let C be chocolate. So let C be chocolate, and then J be jellies. Alright, so if 3 chocolates means that I will say 3 choose 3 over 8 choose 3, because he chooses 3 chocolates, right? 3 sweets at random. So I can say that the selection is done at the same time. So that's why 3 choose 3, right? So therefore, this is going to be 1 over 56. Now, when Px equals to 1 means that you have chosen 1 chocolate, not 1 jelly and 2 chocolate. Okay, so you have 5 jellies and 3 chocolates, so I need 1 jelly. So 5 choose 1, and followed by 3 chocolates, you choose 2 over 8 choose 3. So this is going to be 15 over 56, right? And then when Px equals to 2, I will just count Px equals to 3. Px equals to 3 means that all 3 jellies. So at first you have 5 jellies. So now out of 5 you choose 3. That means it will be 5C3 over 8C3. And then here I will be getting 10 over 56. And then now when Px goes to 2, because we know that total probabilities must be 1. So I will just use 1 minus all these 3 probabilities. That will be 1 minus 1 over 56 plus 15 over 56 plus 10 over 56. So 1 plus 15 plus 10, it will be 26. So it will be 26 over 26. So 1 minus 26 over 56. That is 30 over 56. Okay, so with this, I can just draw the table. This will be the x values and the probabilities. So 0 until 3. So x equals to 2, I get 30 over 56. Px equals to 0, 1 over 56. Px equals to 1 is 15 over 56. And then the other one is 10 over 56. So this is a table, probability distribution table of x. Now, the company also produces large boxes of sweets. For any large box, the probability that it contains more jellies than chocolates is 0.64. 10 large boxes are chosen as random. B. Find the probability that no more than 7 of these boxes contain more jellies than chocolates. So here, you see, contains more jelly than chocolates is with this probability. So that means this is basically binomial distribution. Right? I will just write X is binomial distributed. There are 10 large boxes, so n is 10. And then the probability of containing more jellies than chocolates is 0.64. Because here also more jellies than chocolate. Right? So now not more than 7, sorry, not more than 7 means up to 7. So when up to 7, you have to count from 0 until 7. That means you have 8 probabilities that to be counted. So now I will be using complementation rule because I know that my x is from 0 to 10. Okay, and now less equals to 7 means that 0 to 7. So instead of counting all these probabilities, I will say that is 1 minus, that means total 1, that is the probability of 1, minus 8, 9, 10. Okay, that will be my less equals to 7 probabilities. That means here is going to be 1 minus px equals to 8, or px equals to 9, or px equals to 10. Okay, so now use the formula of binomial. So when x is binomial distributed with np, your probability is going to be ncx, px, qn minus x. Then now, just substitute into this formula, I'll get 1 minus 10c8, 0.64, power 8. Now, what is the q? Your p is 0.64. That means your q is 1 minus 0.64. That is going to be 0.36. Alright, so here I will write 0.36 power 2. Then plus, when px goes to 9, that is 10c9, 0.64 to the power of 9, then 0.36 degree 1. Okay, lastly, there will be 10 successors plus 0.64 to the power of 10. Now, from here, you will be getting 1 minus, now total of the 3 terms inside the bracket, it will be 0.240537. Okay, and at last, you will be getting 0.759463. And now, I round up to 3 significant figures. So 3 significant figures, you refer to the fourth one. Since this number is 4, right, therefore I will just ignore 463 and write down my final answer as 0.759. So that's all for the parts B. Okay, next question, number 4. In a music competition, there are 8 pianists, 4 guitarists, and 6 violinists. 7 of these musicians will be selected to go through to the final. How many different selections of 7 finalists can be made if there must be at least 2 pianists, at least 1 guitarist, and more violinists than guitarists? Okay, so basically you have 8P, you have 4G, you have 6V. Alright, so from here you need to choose 7, then minimum 2P, minimum 1G, and then make sure, right, V is greater than G. So these are the 3 conditions for the selections. Alright, so now I will draw the table. Initially you have 8P. P means pianist, okay, pianist. So then G you have 4, and then V you have 6. Now to get at least 2, so probably I start with 2 first. and at least 1 G. So 1. Now 2 plus 1 is 3. I need 7. That means this is 4. And 4 is greater than G. That is fine. Now probably I will say 2P, 2G. So when here is already 3. It's already 4. 2 plus 2 is 4. I need another 3V. And again, V is greater than G. And then followed by probably, okay, if let's say here 2, here 3 is already 5, then the V is 2. V is 2 cannot because V is less than G. We need to satisfy this. V is greater than G. So I have to erase this combination. Now I will start with 3 for the P now. And minimum 1G. So here 1G. 3 plus 1 is 4. 4 plus another 3 is 7. Again, 3 is greater than 1. V is greater than G. Then now I will continue with, let's say, 3, 2. So here is 5. If here is 5, I need 2 V, right? But then it does not satisfy V and G. V is greater than G. Therefore, this is not acceptable. So I will not have any selections that start with 3P. Okay, therefore I move on to 4P. So when here 4P, remember minimum 1G. So 4 plus 1 is 5. 5 plus another 2 is 7. At the same time, V is greater than G now. So there is no more combination because if you consider here 4, 2. 4 plus 2 is 6. Then this is 1. So V is less than G. That means it's not acceptable. Alright, so now since we need to get minimum 1G, so we impossible to get 5P. Because if 5P, then 1G, then 0V. Alright, so that's all for the combinations. Now I will just write down here my number of selections. So for the first case, 8P I choose 2. That means it will be 8C2. Followed by 4G I choose 1. So 4C1. Followed by 6V I choose 4. So 6C4. This is for the first combination. Now you can choose first or second or third or fourth. All is plus. So now I plus. Now for the second combination, it will be 8C2 followed by 4C2 followed by 6C3. Okay? Or the third combination is 8 choose 3 and then 4 choose 1 followed by 6 choose 3. Or lastly 8 choose 4 followed by 4 choose 1. Lastly 6 choose 2. Okay, here 6 choose 2. So when you calculate all of this, right, if you calculate one by one, the first one is 1680, the second is 3360, and then 4480, followed by 4200. So the total of these four numbers will be 13720. So that's the solution of this question. For question number 5, on Mondays, Rani cooks her evening meal. She has a pizza, burger, or curry with probabilities of 0.35, 0.44, and 0.21 respectively. Okay, 3 different dishes. When she cooks a pizza, Rani has some fruit with probability 0.3. When she cooks a burger, she has some fruit with probability 0.8. When she cooks a curry, she never has any fruit. Now, A. Draw a fully labeled tree diagram to represent this information. Okay, so now, this is pizza, then burger, lastly, curry. So, pizza probability is 0.35, then burger 0.44, curry is 0.21. And now, fruits. here fruits, this one no fruits. Okay, without, or just write no fruits. Then here for burger, same, fruit, no fruit. Okay, and here same. Now, when she cooks pizza, right, probability of having fruit is 0.3. So no fruits will be 0.7. So that the total probability is 1. Now, when she cooks a burger with fruit is 0.8. No fruit, 0.2. And when she cooks a curry, she never has fruit. So it means that here, I shouldn't have fruit. So it means here, it will be no fruit. Or probably you can just write, this is fruit, this is no fruit. Here is 0 probabilities, this is 1. Okay, so this is the tree diagram. Now, B, find the probability that Rani has some fruit. So, when she has fruit, that means she either cooks pizza or burger. Alright, so here I will just write P fruit equals to just times pizza times the probability of pizza times the probability of fruit, 0.35 times 0.3. Or, okay, or is plus. Or she cooks burger and with fruits, 0.44 times 0.8. Then from here, you will be getting 0.457. Now, part C, find the probability that Rani does not have a burger, given that she does not have any fruit. So now here, no burger, right? No burger, given that no fruit. So this is conditional probability because of given that. So here, for your information, PA/B, this is a conditional probability formula, that is PA intersects B over PB. Alright, that means now here I'm getting no burger and no fruit over P no fruit. Okay, so now no burger and no fruit, that means it could be pizza and no fruit, or curry with no fruit. Okay, as long as not burger. Alright, so here I will rewrite. That is pizza and no fruit, or is plus curry and no fruit over no fruit. Okay, no fruit means that it must be, see, you can just use 1 minus with fruit. So 1 minus P fruit. So now from here, pizza and no fruit. Pizza and no fruits is basically 0.35 times 0.7. So 0.35 times 0.7 plus curry and no fruit. So that is 0.21 times 1. over 1 minus probably with fruit. So with fruits means that it is the answer from B, 0.457. So I use 1 minus that value. And then you will be getting 0.455 over 0.543. Okay, that is going to be 0.838. So this is the probability. Okay, now next question, number 6. The lengths of female snakes of a particular species are normally distributed with mean 54 centimeters and standard deviation 6.1 centimeters. Female snakes. A. Find the probability that a randomly chosen female snake of this species has length between 50 centimeters and 60 centimeters. So now I will write F to represent female snakes. It will be normally distributed. Mean is 54. Standard deviation 6.1. So write 6.1 squared. Because in general, X is normally distributed with mean, mu, and variance. Okay, and now you are given standard deviation. Therefore, you need to square it. Now, the question is asking for probability that the female snake has length between 50 and 60 centimeters. So it's between 50 and 60 centimeters. Now, here, we need to standardize it. So when you standardize, it's basically x minus mu over sigma. Therefore, I will be getting P, right, 50 minus 54, that is my mean, over sigma is 6.1. And same goes with the other one, 60 minus 54 over 6.1. Then from here, when you calculate the left-hand side of the value, that is going to be negative 0.656. And then the upper value is 0.984. Now, sketch a graph. The normal graph, which is a bell-shaped curve, it is between negative and positive value. So here is negative 0.656, middle is 0. Say this is 0.984. And now our region is bounded by these two lines. Okay, so what to do here is I can say that I use this concept. Total probability of z less than 0.984 minus the negative value. Alright, so here I will write P z less than 0.984 minus Pz less than negative 0.656. Now for the negative part, right, I need to draw another graph. So I draw another one to show the second probability less than negative 0.656. This is a blue region. Okay, now because the region is on the left side, so I flip. So once I flip, this becomes orange color and the value is 0.656. So I will say that here it is same as Pz less than 0.984 minus the blue region after you flip, because it is symmetrical at origin at the 0. So I will say that it is same as the orange region. So now this orange region, okay, it is same as total probabilities 1 minus Pz less than 0.656. That will be the orange region. Okay, so here you can just write 1 minus Pz less than 0.656. So then here, you just refer to the table, the normal table. First probability is going to be 0.8375. Then you minus 1 minus The other probability is 0.7441. So when you calculate the three values, right, then you will be getting 0.5816. And now you round up to three significant figures. So look at the fourth significant figure, that is 6. 6 you round up, it becomes 582. That is your probability. Okay, now next question. The length of male snakes of this species also have a normal distribution. A scientist measures the length of random sample of 200 male snakes of this species. He finds that 72 have lengths less than 45 centimeters and 17 have lengths more than 56 centimeters. Okay, just now less, now more. Now B, find estimates for the mean and standard deviation for the length of male snakes of this species. Okay, now let M be normally distributed. Mean is unknown. Variance is also unknown. Okay, now it's mentioned that out of 200, 32 have lengths less than 45 centimeters. Means that PM less than 45 centimeters and the probability is 32 over 200. Okay, then from here I will say that PM less than 45 is basically 0.16. Okay, 32 over 400 over 200 is 0.16. Now the other one is greater than 56 centimeters. It will be 17 out of 200. So I will use that information later. Let me standardize this first. Okay, so this will be P Z less than 45 minus mu over sigma equals to 0.16. Now once you have standardized it, sketch your graph. Okay, middle is 0. Now I am not sure where is this line, so I will draw two lines and label. Then I choose the correct line. Okay, remember this probability is 0.5. Okay, so if I refer to the orange region and the probability, because it's less, so therefore the region is towards left side from the line, and the probability here is 0.16. So looks like 0.16 is less than 0.5. That means your line is correct. But if you choose the green line, this whole region is already exceeding 0.5. So this total probabilities of z less than the green line, it should be more than 0.5, which is wrong because now you are given 0.16. So therefore I have to erase the green line. So this is how we check whether it's on the left or on the right. Now since it is on the left side, what I need to do is I flip the orange line to the right side. So once you flip, initially this value 45 minus mu over sigma is a negative value, but once you flip it becomes positive. So this can be done by multiplying a negative to the original value. Okay, and I will label this blue region as 0.16. Then from here I will write PZ less than negative of, more. This is more, not less. Okay, now the blue region means Z more than negative of 45 minus mu over sigma equals to 0.16. Now the table shows the region towards left side, which means, okay, all here, this region, it will be 1 minus 0.916, which is 0.84. Alright. Then I will write down one more equation. I will write PZ less than negative of 45 minus mu over sigma is basically 0.84. And now I will refer to the table because the line is on the right side, right? And then the probability is the region is towards the left side already. So now I will just write from table PZ less than 0.994 equals to 0.84. So now I will compare and get the first equation, because now your mu and sigma are not given. So 45 minus mu over sigma equals to 0.994. Hence, I get the first equation. That is going to be 45 minus mu equals to 0.994 sigma. This is my first equation. Okay, I need to redo all this for the second information here. Alright, so I will do side by side. So it means that now P, the length more than 56. So M more than 56. And the probability is 17 out of 200. So this is going to be 17 over 200. Alright, then now you standardize it. Or probably I can change. 17 over 200 is basically 0.085. And then now I standardize. It will be 56 minus mu over sigma. And again, now I sketch a graph. Okay, I have two lines, right? Either on the left or on the right. So if I label here as 56 minus mu over sigma, and for the orange line, that is 56 minus mu over sigma. Now look at here, this is greater than. That means the region is towards right side. So I label here 0.085. But then when you look at the 0 here, I know that this is half. Therefore, obviously the orange line is the correct line. Because if you choose the green line, it will be more than 0.5. So it means that now I have to erase this. And when you look at the graph right now, okay, the region is towards right side and the line is positive. So the line is positive is fine, but then the region towards right side, we need the other opposite direction, which means this is going to be 1 minus 0.085. So I will get this as 0.915. Okay, so here I will write down P z less than 56 minus mu over sigma is going to be 0.915. Now, again from the table. So P z less than 1.372. That is 0.915. And now we are compare. This is my second equation. So I will be getting 56 minus mu over sigma equals to 1.372, and the sigma move up to the other side, and then I will be getting the second equation. So I will get 56 minus mu equals to 1.372 sigma. This is my second equation. So now I need to solve these two simultaneous equations by looking at the left hand side. Both also minus mu. Therefore, I can just say second equation minus first equation. I'm using elimination method. So 56 minus 45, that is 11. Okay, minus mu minus mu is 0. Then 1.372 sigma minus 0.994 sigma, you will be getting 2.366 sigma. And from here, my sigma is 11 over 2.366. That is going to be 4.649196. And then I round up to 3 significant figures for my final answer. Therefore, I look at this value. It is 5 and above, so I round up the 4. And at last, you will be getting 4.65. So once you have found the sigma, to get the mu, you just substitute into first or second equation. So now I substitute into first equation, right? So now to get the mu, this minus mu move to left side, and this 0.994 sigma will be moved to left hand side. And now I will write down my mu first. That is going to be 45 plus 0.994 sigma. My sigma I will replace by this whole value. So that is 4.649196. Then you will be getting 49.62. And now you round up to 3 significant figures. That is 49.6. So that's all for this solution. Okay, now for question 7. The numbers of chocolate bars sold per day in a cinema over a period of 100 days are summarized in the following table. Now draw a histogram to represent this information. For your information histogram, we need the class boundaries. Okay, so here I will add on class boundaries. So class boundaries is basically the average. So 10 plus 11, then divided by 2, that is 10.5. Then I know that the previous one should be 0, so 0 plus 1 divided by 2 is 0.5. Okay, then for the second class, it will be 10.5 to 15.5, and then 15.5 to 30.5, and then for this class, it will be 30.5 to 50.5, and then for last class, 50.5 to 60.5. So you just get the averages, which are the boundaries. Okay, so from here, the vertical axis for the histogram is number of days, which is the frequency. So now, my class boundaries will be 0.5 until 60.5. So here, I'll just draw a bar, a jump. Let's say this is 0.5. Then, okay, let me check. Or probably, I will just direct label here as 0.5. Then here, 10.5, 20.5, 30.5, 40, 50, 60. Okay, this will be my number of chocolate bars sold. Okay, then for the frequency, maximum 30, minimum 8. So here, now look at the interval first. Okay, so you see the width, class width here. The class width, look at here, class width. 10 minus 10.5 minus 0.5. This is minus to get the class width. So you get 10. Then the next one is 5, followed by 15. After that, 20, and then 10. So since different class width, we cannot use frequency. We have to use frequency density. So now frequency density is basically frequency over class width. Let's say class width is C. So now 18 divided by 10, you will get 1.8. Okay, 24 divided by 5 is 4.8. 30 over 15, 30 over 15 is 2. 20 over 20 is 1. 8 over 10 is 0.8. So now, my vertical axis is frequency density. This is my vertical axis. Okay, so then here, my maximum value is 4.8. Minimum is 0.8. So that means I will just label 1, 2, 3, 4, and 5. This will be my frequency density. Okay, so now you can sketch about now the histogram. So for the first class, right, which is here, I'm referring to this together with the corresponding vertical axis. So first class 1.8, 0.5 to 10.5, 1.8. That means it's over here. Okay, so please draw using ruler so that you get the rectangle. Then next is 10.5 to 15.5, then 4.8. 10.5 to 15.5 is over here. 4.8. So right, this is the histogram. Now the next is 10.5 to 15.5 and it's 2. So 10.5 to 15.5 to 30.5 is 2. Okay, after that 30.5 to 50.5 is 1. So 30.5 to 50.5. Alright, then after that 50.5 to 60.5 is 0.8. Okay, so this is the histogram. Alright, now B. What is the greatest possible value of the interquartile range for the data? So for interquartile range, we need to know the cumulative frequency, right? So it means that now I will copy down these two columns, these two rows that add on the cumulative frequency, right? So I will copy the whole table. So instead of writing the chocolate, I will just write X. This is frequency. Cumulative frequency is capital letter F. So here will be 1 to 10, 11 to 15, 16 to 30, 31 to 50, then after that 51 to 60. Okay, so now you copy the F frequency 18, 24, 30, 20, and 8. Now the cumulative frequency is the addition, is the accumulated frequency, means that now you keep adding, right? And write down the answer over here. So that means 18 plus 24, that will be 42. 42 plus 30, 72. 72 plus 20, 92. Then the last one is 8. So 92 plus 8, 100. Okay, now interquartile range, that is Q3 minus Q1, right? So now I will write down my Q1 first. Q1 is 1/4 of the total. Total is 100. That means it is the data number, or 25th data. So 25th data, look at the capital F, right? this 18 means data 1 to 18 will be in first class. Then the next value is 42. This 42 means that the second class, which is 11 to 15, will contain, alright, will contain data number 19 to 42. And now since our Q1 is data number 25, therefore my Q1 will be in the second class. So I will write Q1 class is 11 to 15. So now Q3, which is 3/4 of the total, this is 75. So again, use the same concept, which means the Q3 will be in 31 to 50. This is our Q3 class. Okay, now you need to find critters IQR, interquartile range. So now right now we only can find the class. That's why you can just find the critters interquartile range, that is Q3 minus Q1. Okay, so which is the highest the upper limits of the Q3 class minus lower limits of the Q1 class. That will be the greatest interquartile range. And then you will be getting 39. So that's the solution for part B. Okay, now part C. Calculate estimates of the mean and standard deviation of the number of chocolate bars sold. So here we need to get the midpoints and also frequency. So I will refer back to this. Right. So then I will copy X, F, then I will write midpoints. This is the midpoint. So copy back 1 to 10, 11 to 15, 16 to 30, then 31 to 50, and then 51 to 60. And the F, just copy the second row right now. 18, 24. Then 30, 28. Now to get the midpoints, get the average. Right, so 1 plus 10 divided by 2 is 5.5. 11 plus 15 divided by 2, you get 13. Then the next one will be 23, 40.5, followed by 55.5. So now the mean. Right, I will say this is X bar equals to summation Fm over summation F. So it means that now you multiply first before you plus. Then I will be getting 18 times 5.5 plus 24 times 13 plus 30 times 23 plus 20 times 40.5 plus 8 times 55.5. Over the total, right? Total is 100. That is the capital F, the last capital F. Then I will be getting 2355 over 100. That is 23.55. And when I round up, that is 23.6 for my mean. Okay, and now we need to calculate standard deviation. So mean, standard deviation. Now for standard deviation, okay, I will start with summation Fm squared first. So I do this calculation first. Now remember, your F is 18, 5.5 is the M, right? Therefore now I need to square the M. I will refer back to this numerator, but I squared the bracket. Therefore, you will be getting this working. So 30 times 23 squared plus 20 times 40.5 squared plus 8 times 55.5 squared. That means the total here is going to be 77917.5. Okay, now your standard deviation is square root of summation fm squared over summation f minus mean squared. Okay, the mean is x bar. So now here I will get square root of 77917.5 over 100 minus my mean. I will use the previous value 23.55. Then you square it and you will be getting the answer of 14.9857. And now I round up to 3 significant figures. So looking at the fourth significant figures, since this value is greater than 5, so you round up the 9. So you round up 14.9, it becomes 15.0. So that's the standard deviation. Okay, so with this, I have completed this paper and also comes to the end of the video. Thanks for watching. Alright, so thanks for watching. If you enjoy watching my video, please like this video and subscribe to the channel, and also share this channel with your friends. Alright, to show the support to this channel, you may just click the thanks button below the below the video. Alright, so and also stay tuned for more upcoming videos. Thank you everyone. Bye.